All right, now we're going to continue our work with linear functions, and specifically we'll be looking at what's called point-slope form, and I'll do an introduction and then a few solved examples. So point-slope form is one of the three common forms of linear equations, the first being slope-intercept form, mx plus b, now point-slope form, and then lastly we'll be looking at standard form. But for point-slope form, it has a definite advantage but some disadvantages as well. I think the main advantage to point-slope form is that it makes it easy to find the equation of a line from a graph, okay? Or the equation, to find the equation from a line if you just know the slope and another random point on the line. You don't need to go through any work of finding the y-intercept, okay? I think the drawback to point-slope form is it doesn't give you the y-intercept. So the m value in point-slope form is, let's see here, that's the same as the m as the slope in slope-intercept form, but these numbers that you'll end up getting in point-slope form are some random point on the line somewhere, not necessarily the y-intercept. Okay, so that sometimes makes it a little bit harder. So as I just alluded to, m is the slope, and x1, y1 represent a specific point on the line, not necessarily the y-intercept. The thing that is most sort of likely to lead to a mistake here are these subtraction signs. Okay, and I'll get those in a slightly different color here. These subtraction signs right here. So we always need to try to remember to subtract off the coordinates of the point that we're working with. And sometimes those will be addition signs if we're subtracting a negative, okay? And the reason we have a subtraction sign is that's how a function, a parent function like y equals mx, gets transformed as we shift it up or down or left or right. We will be subtracting off the new point that we are shifting it to, sort of. Okay, but really just remember that we need to subtract those values. Let's do an example, and I think it'll make a little bit more sense. So we want to determine the point-slope equation of a line going through the point 2, -1 with a slope of -3. So for these, I really always like to write out, even though I've been doing this a long time, I like to write out my point-slope form first. And then I just want to plug some things in. And I'm going to take a few more steps than I need to, I guess, to really show you each step. And I think it's valuable to take all these steps as you do it for the first few times. But eventually you'll probably get a little bit more efficient with it as well. So I'm just going to literally plug in each point or each number. Y minus a -1 equals -3 times x minus a 2. And what I was saying by taking more steps than I need to here is I want to eventually flip that to a y plus 1, but I want to be careful and not make any mistakes and just write it out just by plugging in first. So we can write this out now as y plus 1 equals -3 times x minus 2. And that's our final point-slope equation. Okay, we completed that one. It has a slope of -3, and it goes through the points 2, -1. Let's go ahead and graph, and I think you'll see one of maybe the advantages of point-slope form. Here, it makes it somewhat easy to graph. All right, y minus 3 equals a -0.5 times the quantity x plus 2. So I'm going to modify that a little bit first. I'm going to do two things. I want to make my slope a fraction, and I want to make a formal point-slope form by having everything be a subtraction. So let's rewrite it. Y minus 3 equals -1/2 times x minus a -2. Okay, and so now we have the slope, and we have an x coordinate and a y coordinate. Okay, so the m, our slope, is -1/2, and it goes through this point, -2, 3. All right, just be careful with those negative signs, okay? It's really common to flip some negative signs or to lose them. Okay, so we can just go ahead and plot the points now, or plot the line. We have a -2, 3, so over 2 up 3, so that's a point on my line. And then we have a slope of -1/2, so down 1 over 2, down 1 over 2. We can do this as long as we want. We go in the opposite direction. And eventually we have a nice clear pattern of a line. Pull out your ruler and graph it up. Okay, I think you can see what the y-intercept is now. Okay, it looks like b is equal to 2. So we could also write this as y equals the same slope, negative 1/2 x, plus 2. So those are equivalent equations for the same linear function. Okay, even though that wasn't asked in this problem, I think it's good to try to make those connections. All right, let's write an equation from 2 points now. This will be our last example for this video. And the steps are to find the slope and then to write the equation using the slope in either of the 2 points. And this is the real big advantage of point-slope form. You don't need to go through any algebra to solve for b, for the y-intercept. You can just plug in a point right away. So let's find the slope. And our slope is the subtraction of the y values, being careful with your negatives, divided by your subtraction of the x values. Okay, so this turns into 7 over negative 7, it looks like, which is negative 1. Okay, so that's our m value for this linear function. We have a slope of negative 1, down 1 over 1. Pick any point we want. It doesn't really matter. And we're going to plug that information that I just highlighted into our point-slope form equation. So y minus our y value equals m times x minus our x value. And then we can simplify a little bit. And we're done. Okay? So we just went from 2 points to a point-slope equation of a linear function. And that's a good place to stop right there.